You are once again welcome to Math and Start Up. Today we'll be looking at measures in statistics. Measures in statistics. Now, like I said, that in descriptive statistics, we tend to describe the character of a given population or data in a more explicit manner. Now, measures in statistics, there are various measures that tends to help us in this journey. And various measures, like I said, we have measures of central tendency, otherwise known as measures of location. We have measures of variability, otherwise known as measures of dispersion. We have measures of partitions and likes of them. But today we'll be focusing basically on measures of central tendencies. The measure of central tendency is otherwise known as measures of location. Now, basically, they are just the 3 M's of statistics. The what? The 3 M's. The 3 M's of statistics. And what are the 3 M's of statistics? We have the mean, followed by the median, then the mode. The mean, followed by the median, then the mode. This is actually our statistical tool or statistical methodology that we use in knowing measures of what? Of central tendencies, or basically measures of location. We want to know if our data is centrally based or centrally concentrated. So that is what we tend to look at in these measures. So, and I would like to tell you about the group and the ungrouped data, the grouped and the ungrouped data before we go into our work proper. Now, in the group data, we have data that are within intervals, data that are bounded within intervals. For instance, you have your distributions, scatter distributions, then you're trying to arrange them, but because of their closeness in value, so you tend to group them so that they can be more compact and more organized. So you try to group them. You see something like class intervals, 1 to 3, 4 to 6, stuff of that nature. It tends to group data into their respective cadres. Then the ungrouped data are just your data. They are not closely packed and are not widely spread. So you just sort them out just as they are without grouping them or trying to do any form of manipulation on them. Just sort them straight in that manner. So that may actually lead us to discussing discrete and continuous data. The discrete and the continuous data. So we have the discrete data are data that do not take values within interval. There are data that do not take value within intervals. For instance, when I ask you what is the size, what's your family size, you can't tell me your family size is 7.5. You say why? And because our mother is pregnant. You can't say that because everybody in the family is what they are discrete. So for instance, you can't say we have 2.5 electric fan in our house. It's not possible. So it's either you have 2 fans or 3 fans. There's something like 2.5 because these are discrete data that can be counted using natural mapping. So while the next one is called the continuous data, these are data that can take values within intervals. And the example includes what? Example includes your age, weight, height, and in short, when it comes to this dimension I just mentioned, there are values or there are data that take values in between intervals physically. So you may be wondering, I have to go down to these stuffs. I need to go down there so that I'll be able to bring more light to this work called central of measures of central tendency, which is otherwise known as measures of location. The question is, what is mean? Now, I know you know that mean also have its own meaning in English language. You are mean, like you are being careless or wicked. But the point is that in mathematics or in statistics, mean is actually otherwise known as average number. That is, they are the sum total of a given data over the total number of the data gives us our mean, and it tends to be a very good measure of statistics in the sense measure of central tendency in the sense that it tends to give us a balanced view and a singular numeric value that could represent a given set of data. So that is what the term mean tends to do, and it is being symbolical. It is being denoted by x bar. X bar, make use of x bar. So for instance, you are given a given set of data, say x1, x2, x3, and it goes on and on down to xn. If this was our given set of data, then you are asked to find the mean. It's so simple in the sense that you have your x bar and the sum total of all of your data given, the very sum total of every data given, all over the total number of data, which is your n, basically. So with this, you can easily solve for mean, which is called the arithmetic mean. Okay, so I want to forget. There are other mean. We have about we have various ways by which you can calculate mean, but mean on its own, we could discuss under mean alone. We could discuss the arithmetic mean, the harmonic mean, and the geometric mean. So, but in this class, we're looking strictly at the arithmetic mean. Perhaps not in any other classes, we'll be talking about the harmonic mean and the geometric mean. But here, let us talk about our arithmetic mean. Now, arithmetic mean, I can easily write this as the sum total of my what? Of my xi all over my n, my I ranging from 1 down to n. So I have not written anything new. I've only written this expression in a compact form. Compact form in the sense that this guy implies summation, a Greek letter, meaning the addition of a given set of data. That is what we call the summation. So when I add it up together, I have my x bar. But for instance, what if I'm dealing with a, so this basically can actually work for an ungrouped data. An ungrouped what? An ungrouped data. It could easily work for it. But what if I was talking about a group data? Now, with respect to me, a group data in me tends to do with giving data with their respective frequencies. So, for instance, if this is my given data x1, x2, x3, x4 has respective frequency f1, f2, f3, and it goes on and on towards to fn, then I will say that my mean x bar is what? Is f1 x1, that means the product of my frequency f1 times my data x1 plus my frequency f2 times my data f2 plus on and on and on down to the last data fn xn all over my total frequency, which I have my f1 plus f2 plus on and on and on down to fn. Do you understand? That is just is when I'm dealing with the group data. So if I was to write this in a more compact form, like I've written one above, then I'll be having something of the form, say, the summation of I ranging from 1 down to n of fi xi all over the summation of fi. Then it should be noted that what? It should be noted that what? That your summation fi is otherwise known as capital N. That is your capital N is your total frequencies under consideration. So each of them may be need for me to define some terms to you, and that is frequency, like I just mentioned. What is frequency when it comes to statistics? Frequency is just the number of times that a given data appears in a given set of distribution. The number of times that the data appear in a given set of distribution is simply referred to as what? As the frequency. Under arithmetic mean alone, we have various methods of solving for means, and we still arrive at the same answer. So what I just gave you now can simply be referred to as the direct method of solving for what? For mean, either xi for the ungrouped data, or what? For your summation fi xi over capital N for what? For the group data, with your I ranging in between what? In between 1 and n, such that what? Your I ranging from 1 to n. You understand? But when it comes to solving for mean, making use of the method called the assumed mean, then the assumed mean method of solving for mean, then we will have to just come up with an idea. And the idea is that in your given set of x value, for instance, you have a tabular form of this form, and you have your x, you have your x1, you have your x2, down to your xn. Then you just assume that any of these x is your mean. So for instance, let me say xn minus 1, then my xn if I assume that my what, maybe I say x2, you can assume anything, you can assume x3, you can assume x5, and I hope you know that these are just the notation. Your x5 are numeric values, but we want to deal with them arbitrarily here, so that when you come with across any question, you can easily fix them. But after this class, trust me, you're going to have an example that will make you relate to these things easily. So perhaps you have your frequency f1, you have your frequency f2, down to your what, to your fn minus 1 and your fn. Then you have your f of x to be f1, x1, f2, x2, down to your x fn minus 1, xn minus 1, then your fn xn of this form. Then you can add your formula of assumed mean to be what? To be x bar equals to a plus what? Plus summation fi di all over capital N. Now the question is now, what is my di? Now your d is just what? Is your set of xi's. So you could meet your fi, like I just called them. Do you understand? Your x, your d is your xi minus that you assumed me. That will give us our given set of what, or distribution here. Then I'm going to be multiplying it with my what? With my f, so that I have fdi, fidi, I have my set of distribution as well. So from there I can easily compute for my assumed mean. So the next one is called the coded method. The coded method of solving for mean, and it's easily understandable. You can easily relate with it. So I will just give you the formula, but in our next class I promise to have an example that will break this down for us. So if you are to use your coded method of solving for your mean, apart from your assumed mean, your coded method or your coded mean, either way you want it, either coded method or coded mean, then you'll be having your formula to be of the form x bar equals to what? Your assumed mean is still there, plus what? Your summation f u c all over capital N. Now, when you have your u, when you have your c, your class size, and your u, note that when you have your u is actually what? Your d minus a all over c. And even when after you finish computing this and when you bring it here, you will discover that you still land at your assumed mean. Do you understand? So just stay put. In our next class, by God's grace, we should be looking into examples that will give us light into this in a more understandable and comprehensive way. But please do ensure to share this video with friends and family and subscribe as well. Thank you.